Welcome to today's lesson. We're going to be going over the mathematical calculations involving density. In this first problem, a woman is sold a ring and she is told it's made out of platinum, and the woman feels that the ring happens to be a little light, so she's going to test the ring's density. So she places the ring on a balance and finds that the mass of the ring is 5.84 grams. Now, she also finds that the ring displaces 0.556 cubic centimeters of water. Now, we're going to be talking about the water displacement method in a moment, but that basically is a technique to figure out the volume that the ring occupies. And we'll go ahead and put here 0.556 cubic centimeters. So what we're going to do here is we are going to find the density using the formula mass divided by volume. And what we'll do is we'll go ahead and we'll get the mass of the ring in grams. We'll divide it by the volume in cubic centimeters. And as a result, we're going to get 10.503597112, all these numbers. Well, what we're going to do is we're going to round to significant figures. And if you recall, we're using the division rule. This number over here has 3 significant figures. This number down here also has 3 significant figures. So we're going to round our answer to show 3. So our answer will round to 10.5 grams per cubic centimeter. Now, notice that the density of platinum is given in the question. And if you notice, the density that we calculated is nowhere close. So this is definitely not going to be platinum. So the lady her hunch was right. It is not platinum. Way off here as far as density. Now, let me display here what the water displacement method is. Imagine you have a graduated cylinder filled with water. Let's give water a different color here. So it's filled with water, and let's say that the volume here is 10 milliliters. And what we're going to do is, let's say we dropped a ring or a piece of metal, and we're going to drop it in here. And as a result, this is what happens. Here you have your graduated cylinder once again. And what happens is, when this piece of metal goes in there, the level of the water is going to rise. So imagine now that the piece of metal is inside the graduated cylinder. Originally, let's say the volume was 10. Let's say the volume now went to 12 mLs. If you subtract the difference, which would be 12 minus 10, which is 2 mLs, that is the amount of water that is displaced, and it's an indirect way of measuring the volume of the piece of metal. So we can say that the metal occupies a volume of 2 milliliters. Now, don't forget that a milliliter and a cubic centimeter are the same. So even though we're putting a solid object here and we're measuring in milliliters, we could say that the volume is also 2 cubic centimeters. So just keep that in mind. All right, let's go to the next problem here. Actually, this is just to confirm what we did. As you can see here, mass divided by density. And there's the answer that we got. Here's platinum. And as you can see, it's a fake. Now we're ready to go to the next problem. Okay? So this time, the woman goes back to the jewelry shop. The person there apologizes, and here's what happens. He basically says it must have been made out of another material, perhaps silver instead of platinum. So she gets a new ring. This time she is promised it's made out of platinum. So the mass of this ring is 9.67 grams. and the volume is 0.452 cubic centimeters. So we're going to do the same thing. We're going to get a ratio of mass to volume. So we're going to go ahead and divide here. And after we divide, let's put our numbers here together. You'll notice we're going to round this also to 3 significant figures because both numbers have 3 significant figures. We round. Now I get 21.3938053 and it keeps going, but we can safely round that to 3 significant figures to 21.4 grams per cubic centimeters. And if you notice, this time it does match. So this ring is indeed platinum. Okay? So same concept, mass divided by volume, and we got that the ring is platinum. All right. Here's another example. This time it says a gasoline in an automobile tank has a mass of 60 kilometers. And they also give you the density, 0.752 grams per cubic centimeter. The question is, what would be the volume in cubic centimeters? Now, if you recall, one of the formulas that we can use to find volume is that volume is mass divided by density. So we can do that. Now, notice that in density, the mass here is in grams and over here it's in kilograms. So we have a little problem. We need to convert the mass from kilograms to grams. And one way to do this is you simply multiply by 1,000, or you move the decimal point 3 spaces to the right, and the mass ends up being 60,000 grams. Now the volume, the density is 0.752 grams per cubic centimeter. Now what's going to happen is when you do the division, the grams are going to end up canceling. And the number that we get a pretty big number here. We get 79787.23404. And if you look at our numbers, look at the original numbers. Density over here has 3 significant figures, 1, 2, 3, and the mass also had 3. Always look at the original numbers. Notice in the question that both numbers given had 3 significant figures, so we're going to round our answer to 3. And remember that the 8 will bump that 7 up, and that's going to end up becoming 798, and then you got to add a couple of zeros here as placeholders. Another thing you could do is put it in scientific notation, and it's 7.98 times 10 to the 4 cubic centimeters. So here you have the answer either in long form or in scientific notation. And as you can see here, you could have also used dimensional analysis, use a conversion factor, but you definitely have to convert the kilograms to grams. And then they did this one using density as a conversion factor, where they converted and found the volume using this other technique. And here's the setup if you want to take a look at how it was done using dimensional analysis. But you could simply just plug it into the formula, solving for volume, and just get the mass in grams and divide that by the density, and that will give you this same answer here. Okay, let's try this skill builder. So you got acetone here, which is nail polish remover. They give you the mass. Notice it's in milligrams. The density, notice the units. It's in grams per cubic centimeter. So they're asking us for the volume once again in cubic centimeters. Now, in order for this to work, we need to have milligrams be converted into grams. Now, in order to do that, we're going to use the same formula, mass over density. But to go from milligrams to grams, okay, if you notice here, if you're using the grid, what we're going to have to do is we're going to move the decimal point 3 spaces to the left, we're going to end up dividing by 1,000. So if you move the decimal 3 spaces to the left, it would be 1, 2, 3. And the mass would end up being 0.035, but now it's in grams. And the density, let's go ahead and fill that number up. That's 0.788. And the same thing's going to happen. The grams are going to end up canceling each other out. Now, let me write the full answer I got here. I got 0.0441624. And if you look at the question, milligrams has 2 significant figures, density has 3. You always want to go with the lowest, which would be 2. So the leading zeros here don't count. This is your first significant digit, and this is your second. You're going to stop right there. Next to it, it's a 4, so that's not going to affect it at all. And you're going to get 0.044 cubic centimeters as your volume. So that will be the answer to this skill builder. All right, let's take a look at another one here. So here they're giving you a volume, a cylinder, a steel cylinder, has a volume of 246 cubic centimeters. They also give you the density, 7.93 grams per cubic centimeter. Right now the units look good, but notice they want the mass, but they want it in kilograms. So the formula to find mass would be mass is density times volume. So why don't we do that? Let's put these values into the formula. So the density is 7.93 grams per cubic centimeter. We're going to multiply it by the volume, which is 246 cubic centimeters. Look what happens. The cubic centimeters will cancel out, and you're going to get a mass of 1950.78 grams. Now, we have to do an extra step because they want us to go to kilograms. And to go from grams to kilograms, if you look at the grid, all you do is you're going to divide by 1,000, which means you're going to move the decimal point 3 spaces to the left. So if I were to move this 1, 2, 3, your answer would now be 1.95. Now, I'm going to stop there as far as significant digits because notice I need 3. Both numbers had 3, so I'm going to round my answer just to show 3 significant figures. And I also converted it from grams to kilograms. So our answer is going to be 1.95 kilograms. Okay? All right, let's take a look at this next problem. So here we have a chemist needs a 23.5 kilogram sample. So that sounds like mass to me. I look at the next sentence and it looks like they're looking for the volume, but they want it in liters. Now, they do give you the density of ethanol, which is 0.789 grams per cubic centimeter. Now, we've done a problem like this already where to find the volume, you simply get the mass over the density. So let's go ahead and write that down here. Let me go ahead and fix this. So notice that the mass is in kilograms, but density has the value. Notice it says grams per cubic centimeter. So what I'm going to do is I'm going to get this mass and I'm going to change it to grams. And to go from kilograms to grams, you basically multiply by 1,000. If you look at the grid, you move it 3 spaces to the right. And the mass, when you do that, ends up being, you go 1, 2, 3, add a couple of zeros, and your mass is 23,500, but now it's in grams. Okay? So then we're going to divide by 0.789 grams per cubic centimeters so that the grams cancel out. Now, the answer that you get here, I'm going to write the full answer, you get 29784.53739 cubic centimeters. Now don't forget that a cubic centimeter and a milliliter are the same thing. Okay? Remember we said earlier 1 cubic centimeter and 1 milliliter are equivalent. So they want the answer in liters. So what we're going to do is, if you recall, to go from milliliters to liters, okay, you are going to go 3 spaces to the left if you're using the grid. In other words, you're going to end up dividing by 1,000. So if I were to move this decimal point 3 spaces to the left, and I go 1, 2, 3, okay, and look at the values given. This guy has 3 significant figures. The density has 3. I'm not only going to move it 3 spaces over, I'm also going to round it to show 3 significant digits. So you know we got a 29 here. We got the decimal point is now going to be here, and then that 8 will bump the 7 up. So your answer ends up being 29.8, and it's now in liters. So not only did I convert it to liters, I also rounded 2 significant figures. Now this is a sample problem, so you can see here they did it a more complicated way. The book used dimensional analysis, but you could see here they're converting kilograms to grams, which we had to do. Then they used density as a conversion factor to find the volume in cubic centimeters. This step here is just letting you know that a milliliter and a cubic centimeter are the same. And then the last step is to go from milliliters to liters. These are all the conversion factors that we ended up using. Now, you could do it using dimensional analysis like you see here, or you could use the grid. Here it is all set up for you. This is what it would look like using dimensional analysis. Notice they rounded the answer to 3 significant figures. The 8 bumped that up, and that's the answer that we just got in liters. All right? Now, let's take a look at the Skill Builder Plus. So you got a pure gold medal bar displaces 0.82 liters of water. So that's your volume. And notice it's in liters. Now, they want to know what would be the mass. Notice they want the answer in kilograms. And they do tell us that the density of gold is 19.3. The problem here is that we need to convert the liters, okay, to milliliters, because a milliliter is the same thing as a cubic centimeter. So remember, to go from liters to milliliters, you basically multiply by 1,000. You're going to move the decimal point 3 spaces to the right. And when you do that, and I can go ahead and do that now, you're going to get 820 when you move it over 3 spaces. And it's now milliliters, which is the same thing as cubic centimeters. Now, remember that mass is found by multiplying density and volume. So to find the mass, we're going to get the density of gold, which is 19.3 grams per cubic centimeters. You're going to multiply it by 820 cubic centimeters. This will give us the mass. Notice how the cubic centimeters cancel. Now, when we calculate the mass, notice how our answer will be in grams. I got 15826 grams. So we need to convert from grams to kilograms because that's how they want the answer. And in order to go from grams to kilograms, if you look at the grid, you got to divide by 1,000 or move it 3 spaces to the left. Now, the decimal point at the moment is at the end of the number. So we are going to have to go 1, 2, 3, and we end up getting 15.826 kilograms. Now, let's take a look at significant figures. This guy has 2. The density of gold had 3. So we want to show 2 because it's the lowest. So notice the 8 will bump that up. So when this gets rounded, it ends up being 16 kilograms as your final answer to 2 significant figures. Okay? All right, moving right along here. We got one more sample problem. So here we got a person that, I guess we'll put the mass here, 55.9 kilogram person is displacing, so we're looking volume here, 57.2 liters of water when submerged in a water tank. So this one's a very creative question. They want the density, but they want it in grams per cubic centimeter. So really all we got to do, or one of the easiest things to do, is let's convert already the mass to grams. So if you notice, to go from kilograms to grams, you're going to move the decimal point 3 spaces to the right. You're going to multiply by 1,000. So that becomes 55900, and that's already in grams. And then the liters on the bottom here, you want to convert to milliliters because it's the same as a cubic centimeter. And to go from liters to milliliters, you're also going to multiply by 1,000. You're going to move it 3 spaces to the right, and you end up getting 57200, and it's milliliters, but it's the same as a cubic centimeter. So now, all we need to do, and this actually has been very well simplified, we want to find the density, which is the mass over the volume. So the mass is 55900 grams. The volume is 57200 cubic centimeters. And when we divide this, okay, I'm going to write the full answer here. I got 0.977, and then it repeats 2727, and it keeps repeating. Now, if you look at the original problem, this guy has 3 significant figures. This guy has 3. So we're going to round our answer to show 3. And notice that the units are already grams over cubic centimeter, which is what we want. So our final answer, once it's rounded, it'll end up being 0.977 grams per cubic centimeters. And I'll leave it right there. So that'll be the answer. Okay? So we have one more that we're going to do, which has a little challenging component. Here's the answer that we just got. Notice how the mass was converted from kilograms to grams. They used dimensional analysis. The volume was converted from liters to milliliters, which is the cubic centimeter. Here is the conversion using dimensional analysis. This is showing that a milliliter and a cubic centimeter are the same. Here is a confirmation of our answer. All right, let's get to this last problem. So what we got here is you got a gold-colored pebble found in a stream. They do give us the mass. It's 23.2 milligrams. Okay? The volume is also given at 1.20 millimeters, And they do want the density again, but notice they want it in grams over cubic centimeters. So here, this one's a little bit more complicated. The numerator should not be a problem because we're going to convert milligrams to grams. And to go, if you think of the grid, you're going to go 3 spaces to the left. You're going to end up dividing by 1,000. So when you move it 3 spaces to the left, you're going to end up getting 0.0232. And there you have your numerator in grams. Now, where it gets interesting is how to go from millimeters cubed to cubic centimeters. Okay? Now, some of you may know how to raise a conversion factor by a power. We're going to have to actually use a technique here that you may or may not be familiar with. And the conversion factor is that a centimeter has 10 millimeters. So, look what I'm going to do. I'm going to put here 1.20 cubic centimeters. And I'm going to write this conversion factor like a fraction. I want to get rid of the word millimeter. So I'm going to put 10 millimeters on the bottom and 1 cubic centimeter. I'm sorry, 1 centimeter at the top. Now notice over here it's cubed and over here it's not. So here's what we got to do. We got to get the conversion factor, and to make everything the same, we're going to have to cube it. Now, when you cube this, what you get is you still got 1.20 cubic millimeters, and then the conversion factor here, you got to cube everything. 1 times 1 times 1 is 1. Centimeter times centimeter times centimeter is a cubic centimeter. So over here it becomes 1 cubic centimeter. And then the bottom is interesting because you got to cube that. 10 times 10 times 10, okay, would be 1,000. Millimeter times millimeter times millimeter is a cubic millimeter. So what's going to end up happening now is that to go from a cubic millimeter to a cubic centimeter, you got to divide by 1,000. And when you divide by 1,000, that gives you 0.0012. Okay, and now that's in cubic centimeters. So let's do this. We know that density is mass over volume. Well, we got the mass here, so let's write it down. And it's already in grams. Here's the volume, 0.0012 cubic centimeters. Our job is to find density. Now, when you divide this, and we can look at significant figures already. Notice he has 3, he has 3, he has 3. Well, really, this one here doesn't matter. He's not part of the problem. The 2 pieces of information that we used had 3 significance each. So I'm going to round my answer to show 3 significant figures. Gentlemen, here's what I got. I got 19.3 grams over cubic centimeters. And then I'm going to compare this answer to the question that says that gold has a density of 19.3, and I can confirm that it is gold. The density is right on the money. Okay? So this one, what makes this one more difficult is when you're going from a cubic millimeter to a cubic centimeter, you're actually dividing by 1,000. Okay, so one technique of doing this, or one way of doing this, is by cubing the entire conversion factor, and that's how I got what you see on the bottom. Okay, so this is probably the most difficult one of all the problems that we've done, but you've seen that we have, there's problems where we're going to find density and you just divide mass by volume. Sometimes you're going to be asked to find mass, and what you do is you get the density times the volume. And there are going to be times where they're going to ask you for volume, and that's found by getting mass divided by density. So these are basically the 3 formulas where you are asked to find one of the 3 missing pieces of information, whether it's density, mass, or volume. And that'll conclude our lesson for today.